The next thing we're going to learn about is how to do applied max and min problems. That's what we mean when we say optimization. So just like related rates, these are word problems. You have to come up with the equations, and it can get, that part can get a little tricky. So what we want to do first is identify everything we're given. We need to make sure that our equation to be maximized or minimized only has one independent variable. So sometimes we need that extra equation and use the method of substitution to combine them. We do have to make sure that we prove that what we get really is a max or a min using either the first or second derivative test. So example 1, go ahead and pause and read the example. And hopefully you just read that we have two identical rectangular corrals. We don't know the dimensions of either one. So I'm going to go ahead and call that guy X, which means this is also X. And we end up having 4 of those. My vertical distance is going to be called Y. And when you read this, the word in this problem that tells us we're going to do calculus is largest. And so that indicates that I need to find the maximum of an area equation. So to find max, I find the derivative, but I need that equation first. So area for this guy is going to be length times width. My length is x plus x, or 2x, and my width is y. So this is what I'm going to differentiate. The problem is that we have 2 variables on the right-hand side, and we only want 1. So we need to come up with a secondary equation, and hopefully we have more information in the problem. We do know that we have 100 feet of fencing. So that's kind of like perimeter of each corral. But just remember, this guy, this fence down the middle is shared. So we're only using that once. So my equation says we're going to take 100 feet of fencing, and that has to cover 3 y's, and it has to cover 4 x's. You can see that from the picture. So we're going to go ahead and simplify and solve for a variable so that we can get a better equation to differentiate. So I'm going to go ahead and get x by itself. So in this case, we're going to minus 3y on both sides, and we get 100 minus 3y equals 4x. Then we're going to divide by 4, and we're going to get 25 minus 3/4 y equals x. And so we're going to plug all of that in here for x. So my area is really equal to 2 times 25 minus 3/4 y times y. And it's up to you whether or not you want to distribute. Usually it probably will make the problem a little bit easier, but not always. So if we multiply both of these in and distribute, we're going to get here 50y minus, in this case, we're going to get 3 over 2y squared. And so now we're going to differentiate so that we can find our critical numbers and find our max and our min. When the 2 comes down, we're going to get minus 3y. And when I find criticals now, I'm going to get 50 equals 3y. And when I simplify, I see that y equals 50 divided by 3. I do have to prove that this value really is a maximum. So here's where we have our choice of first or second derivative test. Usually you're going to want to use second derivative, but not always, because usually these are nice, pretty polynomials. So the derivative of this is negative 3, which is always negative. So this guy's concave down. So this concave down because this guy's negative. And so that means my function will look like this, which means that y equals 50 over 3 is a relative max. All right? And then we just need to go and make sure that we answer the question. And the question says, find the dimensions. And the dimensions on our original are x and y. And we just found that y equals 50 divided by 3. And so we got to go back now and find x. So we're probably going to use the secondary equation that we plugged in. And that's going to be this guy right here, because it's already solved for x. So x is going to equal 25 minus 3/4 times 50 over 3, and that will give me the dimensions of the x value. So those cancel, and we have 25 minus, if I simplify the resulting fraction, I get 25 over 2. So if I take 25 and I subtract half of it, I'm still left with 25 over 2. And so you would write in a sentence, the dimensions of the corral are going to be 25 over 2 by 50 over 3 feet. And our last example here, again, go ahead, pause the video and read the question. And hopefully you saw that we have a box. It is open, so we're not going to include the top there. It does have a square base. So whatever you choose to represent one side length is also the width. And then the height we don't know, so we're going to use h there. The question in here that indicates we're looking for calculus is going to be maximum. And we're maximizing volume. So that's where I'm starting. I need to find the volume of this shape. And so volume is going to be length times width times height, or in this case, b squared h. And remember, we only want one independent variable. So we need to come up with a second equation, and we really hope that we have information in the problem to be able to write another equation. So we know that 108 square inches is the surface area of this problem. And so if we find the area of the base, we get b squared. And then the area of one of these sides is going to be b times h. And because it's a box, there's going to be 4 of those. So we need to solve for one of these variables. So we're going to get h by itself here. So we have 108 minus b squared equals 4bh. And now we're going to divide by 4b. And so h equals, in this case, let's go ahead and simplify this. So we'll get minus b, and then 27. And then there is a b down here on the bottom. And so now we're going to take this and we're going to plug it into our other equation. So b equals b squared times 27 over b minus b. And here we're definitely going to want to distribute because that's going to allow that b to cancel in the bottom so that we get 27b minus b squared. So in order to find the maximum, we find the derivative. We set it equal to 0. And we simplify. So 27 over 2 should be the length of the base. And to prove that that really is a maximum, we can use the second derivative test. Second derivative is negative 2, which is always negative. So this guy is always concave down, which means b equals 27 over 2 is a max. And again, the question asks me to find the dimensions. So I'm going to take this and I'm going to plug it in for b in this equation so that I can find the height.